No, I just put it there so that you have enough time to change it.
Okay,
You can put 3 hours or 2 hours.
Okay.
You could try that. You could try it in parallel with the create as you can. You might say, sorry, you can't read UK.
Yeah, I'll do
You can't under that name, and then you can say, hey,
I sent you an email, how you send it, because when I run the, I think run the homework, we will have a problem.
yes. So the problem is area.
This is
have this problem.
yeah. This you don't need to care. No, just ignore it.
Yes,
Yeah.
I can't.
Yes, everyone receives this. So I don't know what's happening. Because it's weird because you're actually signed up for the mailing list, so you've done something.
No, I don't.
Yes.
It's great. And
It's asking-
yes.
Yes.
All I can suggest is go through the process again.
Last time
I mean, like deleted or
No, it wasn't on the
The fact that the
usually forget that it's welcome on the list of the users. That's all.
You have Anaconda already installed on your machine?
No, we don't set it. And then the next you have the file is conda install.
First and last.
Okay, so you go through the steps that are listed?
yeah.
Okay.
Okay.
Try again.
By my situation, any methods that to generate SSH key involve software that I need admin rights installed. So I won't be able to do it today.
Okay, and then
That's fine. Even if you could, you wouldn't get access to it.
Yeah, no.
It takes some time to upload. You have your own laptop? Okay.
There's a command.
It's no problem, right?
Let's do it in a different way.
Okay. So I suggest do it on your laptop.
We will do it like this. Conda. No.
Okay.
Bin. Conda.
Yeah. So sorry, guys.
Conda.
This was the key message from the very first lecture. So you could ignore anything I said in the first lecture, but make sure you get the HPC account set up. You weren't there, so you missed this message.
Okay, now it works.
And this was to mitigate this.
I don't know why this.
Off-stage
He should set up some.
Okay.
So the conda is different.
It's in the Anaconda.
Why did you
It's like a like a program which makes things. Okay. So you can go.
Yes. Thank you.
And the same for here. So Conda, you use this Anaconda citation.
Okay.
The one with
Did a bachelor's in physics, math and programming. It was a general bachelor's in physics, math and programming.
Okay. That's a good.
Okay, and it's in.
If you have this background, you'll know.
There is money, and I don't know. Yes. Can you run this installation? Like yeah. So
And then
we
I
want
get
like
it.
once you
And
have
so
SSH,
that's
then
how
you
you
have to
this one.
so your SSH of your so if the
She's
put
done
this,
What do you want?
Yeah.
Yes, she's in there. She's in there.
can you open the
So it's just this.
yeah.
So they just need to access the key, I guess.
From here, we take this command. So this is for everybody.
Yeah.
I mean, once you have logged into the, maybe I can explain this. So once you have logged into the front end, then it doesn't matter whether you have Mac, Windows, or Linux anymore, because then everything is done on the front end. So the only thing is how to access HPC. Then it matters whether how you access. But once you have accessed HPC, you are on the front end. So these lines apply to everybody, independent of the operating system.
Okay. Do not show this message again.
What does it say?
Paste it. Paste the following lines.
Zero, one.
Did you change the password?
Right, okay.
No, I didn't change the password, but that's
Can I try again?
It's working.
So you can install the yes.
There's the same password that they had given us. I suppose. This one.
Yeah, but
you need to write at the
See, the thing about screen is
Yes, now you can, once you have access to the
Okay,
computation,
great.
you'll know.
Thank you very much. Because I didn't know how to.
you may log into.
So what is the HPC IPA?
So just run them blindly.
If they ask questions, we can.
Okay. And if you want to understand what each step does, you can read back. And that's 1 hour.
How do I skip these introductions?
I think we need to one week
Pretty good. It's okay if you have a session to mitigate this, because next week is anticipating there were going to be problems this week. And there's going to be some problems. It's okay. Yeah,
So we make this installation for a few of you, and then maybe you can also help each other. If not,
Yes.
we can try next.
Yeah. Maybe in 1 minute I'll come to you. Maybe we should move on with the course. So you might be worried that we've lost an hour and that we're behind, but we've anticipated there might have been problems this session. This is the most important session of the course, because this is when you get the main assessment. But it's okay because we anticipated this and we've assigned an extra week. So on the 5th of November we will be doing the same stuff again. Okay. So there's a chance to come back and go through everything together. So perhaps I'll come to you.
So you can maybe help with the installation, and then I will explain you a bit the.
Yeah.
So you have this file in Moodle, so you can run the installation. And in the meantime, I will give you the background on the case study. And once it's installed, then we can see and run it together. And next week we will continue with
One is already about the solution of the problem. They are existing. This, in this case, is about the server, so creating account and managing account.
So
Administrator, I suppose.
from the thing.
So maybe you could forward as well. So just
is it working?
No, it's also have the arrow. I don't know. I can't use this part. I don't know. It also has the arrow.
Okay, so maybe I will. No, this you don't worry about. I mean, that this is the old version. It's okay. But you can do the same thing. So you can actually use this. So Anaconda, bin pip, and then install. Please do the same for all of them. Because I don't know what happened in this. Just.
Your account you have this address to support.
maybe you can just.
Yeah, it's okay. Please just do. I will update the file. Okay, so maybe once you are running this installation, I will continue with the lecture.
One
So,
problem.
okay.
After I install or I run the shell script, it's installing Anaconda,
Yeah.
but afterwards I don't have it installed. I cannot use Conda as a factory.
Changes where you're able to access your account.
Okay, so we have seen this problem. So it seems, I don't know, but it seems there is a difference between staff account and a student account at HPC. And to overcome this problem, I will update the installation file. But what you have to do when you write this conda install, and then you have the package name, or you have this pip install, okay? There is some configuration issue. So please replace conda and pip with the following. So you take this Anaconda, because your Anaconda is installed in your local folder, so this is Anaconda 3. Then you take bin, so this is the binary files, and then you say conda. So you give the full path to the conda, and you do the same with. So you put the dot in front.
In home directory.
In your home directory, after running the installing the Anaconda, you should have Anaconda 3 in your home directory, and then you basically replace Conda and
it worked here.
Which is now?
and then whatever follows, and then it should be fine. Because we had the same problem. It seems that there is a difference between staff and students accounts. So some paths are not set up automatically. We just tried with changes before the lecture on a fresh account, and you could just, you didn't need to do this, right? You could just use Conda and if it was installed. So I think there are some differences. I will update the file. Okay, so let's, if you have any problems, you can ask, maybe go also changes. And I will continue with the lecture so that you have some background for the case study. So the difference with our previous lecture, maybe I go directly here, you can read the text yourself, but I will just explain the main parts. So what we have seen last week was this kind of architecture. Okay, so we had an input layer, we had an output layer, some hidden layers, but everything was connected. Okay, so every node in the network was connected to every other node in the, every node from one layer was connected to every node in this consecutive layer. Okay, this was the architecture that we were looking at. And this is useful. We have seen some examples that it can perform well, do some learning and help us to analyze data. However, now we are switching from, let's say, tables, data in form of tables, to images. Okay, and the images require a slightly different type of architecture. There are some reasons for that, but mainly the problem is that if we would have to put in an image, each neuron from the input layer would represent one pixel. In fact, this is even not true. We would have to have, if we have an RGB image, where we have red, green, and blue colors, we would have to have three input neurons per pixel. So if you imagine that you have an image, satellite image, which is of size roughly, well, our image will be like 200 something megabytes. So you have the resolution of thousands by thousands, basically 4,000 by 2,000 or something like that. So this input would be huge. And then even more, you would have a huge number of connections, which boils down to a huge number of parameters. And this makes that one thing, you have to spend a lot of time to train such a network. Second thing, even you train this network, it will be kind of useless. Why useless? Because with such a number of parameters, you can basically fit anything. And the network would be kind of tending to overfit your problem. Okay, if you have, this is just a general description, but this is how people came up with this new kind of architecture. So the neurons in the new type of architecture are organized in layers, but the layers now are not like one-dimensional like we had here. So we had only, let's say, neurons organized in a layer in a row, but they will be organized in some kind of, let's say, cubes. Okay, and there will be some connections between them, and usually the connections will be kind of restricted. Not everything will be connected to everything anymore. And actually, there is reason. This is actually how our brain works. So people were investigating how our eyes are working, and it turns out that if we look at our human visual cortex, it's exactly what happens is that actually we are not, our sensors in the eye are not getting the full image that we actually see. They are only collecting some part of the image. And this is explained a bit more in detail schematically here. So what happens is that if we have an image, and this image is repeated 3 times because let's say we have RGB channels, so we have 3 channels. So each neuron in the consecutive layer, let's say the first input layer, is going to see only part of the image, some kind of restricted or limited, let's say, patch on the image. So this information will come to a neuron here. And the neuron which is next to it will see another part of the image, but this part will be somehow overlaid with this part. Okay, so they are going to be organized in such a way that the consecutive neurons in these layers, they don't see everything, but they see only parts of the image, but also in such a way that neurons which are nearby, they kind of share some kind of part of the information between each other. Okay, so these connections there are much less connections in result compared to deep neural network that we have seen last week. And these layers are then, this is the general idea, these layers which form this convolution layer, you can read more in the appendix. I have put some more detailed explanation what exactly this convolution layer is. If you are interested, you can read more on that. But this basically makes some transformation, somehow summarizes this image, parts of this image, and transforms it into a different dimension, and this information is propagated to the network. So basically we have a convolution layer with this, we have already seen, an activation function for the neurons which are in this layer with this type is ReLU, so the function we have seen last week. Then what happens, actually not all neurons or not all information from here is taken, but this information again is summarized, so kind of, let's say we have some neurons are excited here, and for example what we can take for this neuron is just the average value from these neurons, okay? This is called pooling, so we are kind of reducing the amount of information that is propagated to the network by summarizing the information on consecutive layers. And then once we have the pooling, usually then we again apply it to a convolutional layer. So this is like a number of convolution pooling layers that are stuck one after another. And finally, once we have the last layer, what happens is actually we have a standard deep learning network, which is used further for classification. So this example is to classify images. We see an image and we want to say what type of image is this. Is it a car, truck, van, bicycle, what kind of vehicle it is on this image. And this is a general kind of a description of the architecture. So usually what you have somehow limited connection between the neurons. You have these kind of convolutional and pooling layers which are interchanged, and then finally you end up with a classification. For this example, network which is now fully connected deep learning network. Okay, so this information is somehow summarized. So this image is transformed into some information with this feature learning part of the network, and these features are now a much smaller, concise representation of the image, which are fed into our, let's say, already known deep learning network, which performs the classification. This is exactly what we have seen last week, where we were classifying this ionosphere into good or bad. So we had just two values, and we had only 22 features here, so we could just apply this. So this idea with this feature learning here is to transform the image into some kind of a concise representation which still somehow contains the characteristics that are important from our point of view for performing the classification. Now, how this is done, we don't know. We will not know because we are going to train there are a huge number of neurons here. And actually we will see this vector, and we can see the vector. I mean, this we can access. We will not do it, but it's feasible. We will just see some, let's say, I don't know, hundreds or thousands of numbers, and that's it. So each image will be transformed into a vector of numbers. And once applied to the classifier, we will see that we can get some kind of good results. Okay? So to summarize, this we have seen last week. This is our classification, say good, bad, or what kind of image it is. But before we can perform the classification, we need to find a representation for our problem. So we kind of abstract this image into some kind of vector representation, which hopefully, or by learning, we make it that it contains the relevant information that is useful for performing our classification task. Okay, so this is the general concept, and actually we will not understand much more of that. I mean, nobody actually understands what exactly. I mean, this is like a general idea, general concept, but what these numbers are, what are the weights, we don't know. What kind of representation these are just numbers. It just works. Okay, so this is the moment where we are not able, where the neural network seems to us like a black box. Last week we still could do some kind of analysis. We could do some reasoning. I was showing you like you have linearity, non-linearity. You could do some exercises and think about the structure of the network. Here it is not possible anymore. And actually people are writing papers like they were saying, okay, we have a convolutional neural network. This was already something deep and we're providing very, very good results. And nowadays, you just experiment, you try with different layers, you try to build a network which is suitable for your task. But actually, there is not much reasoning you can do on how exactly these neurons should be organized. It's more like trial and error process. So this is exactly what we have when we talk about convolutional neural networks. So they are not only, but nowadays mainly used for image analysis. So you have images, you already think about convolutional neural networks. But there is more. So this is a recent concept, and I think it's from 2014, right? GANs, yeah. So this is a very, very recent thing, and this was a great breakthrough. So now people thought, okay, so about training. So what we want to generate images. This is now our task. Okay. So we want to generate images that are that look like real images. Okay, of some type. And in this example, we want to generate images of numbers. For whatever purpose, but we want to generate images. And what happens here is that the idea was, okay, if we have images, we will have a convolutional neural network, and it will produce, in fact, it's like a reversed convolutional network, which actually will work kind of the other way around, will produce some noise, which will input to the network, and the network, run the reversed way, will produce an image, and we will train it in such a way that it produces numbers, okay? Some like handwritten numbers. Now, the problem is how to do the training of such a network, okay? And the idea is, let's use two networks. One network will be generating the images, and the second network, called the discriminator, will assess whether the image is real or not. So it has as an input training set of real handwritten images, and it's just doing comparison and saying, yes, it is real, or no, it is not, okay? So then this is the generated image, and this training set is provided to the discriminator, and then the discriminator says whether the image is real or fake. Okay, and of course, because we have the learning process, they kind of both are going to learn against each other. So now the concept is that we can think about this as a generator, which is an artist, which generates images, and the discriminator is an art critic who is saying whether, okay, it's good art or not. Okay, so you can think about this. And by doing the training, it produces more and more realistic images. So what is happening actually is this. So we have first attempt, and we want to, let's say, generate images of cats. The first attempt will be something, just some noise, basically. Okay, so the generator. So the discriminator says, okay, this is fake. But it says that this is fake, so the generator has the information that, okay, it has to do better, okay? So it has to train some different parameters. And then, after many attempts, it will start to generate something which looks more or less like has a shape of a cat, okay? The discriminator is also training at the same time, so it will be even better at selecting whether the image is good or not. But finally, what will happen, is that we are generating images that are almost perfect. I mean, human eye cannot really say that this is a false image, and the discriminator is going to say, okay, this is a true image, and once there is some kind of an equilibrium which is reached, then basically we can stop, we can forget about the discriminator, we type the generator, and we will use the generator to generate images. And in our case study, we'll do the same process. It's just that generator will not produce some random or images of a certain type. It will be trained to remove clouds from our images. Okay? So the training of the discriminator generator will be kind of targeted at good generation of images which are cloud-free, basically. So this is the concept here. And if you check a little bit, if you are interested, you can check on GANs and these image generators. And then nowadays it turned out that this is just a side comment here. This is a huge problem because what we can do, we can generate images of people who don't exist, basically. And this is a huge problem because people are using it for fake documents. For other purposes, and basically humans are not able to distinguish whether this is generated or not. They are so realistic that with this training you can really generate really good images. Okay, but we are not going to produce any false documents. We are going to use it for like a good purpose. Let's say we want to improve on the images. And in the paper, we will see the so-called conditional generative or multispectral conditional generative adversarial networks, which means that they are conditional, which means that they kind of are getting some kind of, let's say, hint or some additional information, which is used to produce an output which is somehow related to this condition that is included. In our case, this is that we provide the RGB image with the cloud, but we also provide the NIR image. This is our kind of condition. And multispectral, because these images are not, these images are multispectral. So the authors kind of sell this network as multispectral because it is used for images which don't contain only RGB but also contain additional information. Actually, in this training, this information is not used, but they also say, okay, NIR is kind of a dimension, and this dimension is taken into account, so they call it multispectral conditional generative networks. Okay, and this is the architecture of the generator. So,
but if these images have infrared, I'm guessing that's infrared, right?
Infrared. Near infrared.
Why remove the clouds if you already have? I mean, you can get a picture of the ground without the clouds.
So yeah, but the problem is that, I mean, this information. So the idea is that you reproduce an RGB image, right? I mean, the NIR, it tells you only some information about what is beneath the cloud, if any, because also it's quite limited. I mean, the NIR cannot go through thick clouds. So they do it for, let's say, they call it filmy clouds or thin clouds. So it will, and this is actually part maybe of your part of the project, that you will try to see how this network behaves on different types of clouds. Okay, so we have the NIR information, but the NIR is also, I mean, it's just providing some kind of information about what is beneath. But what we want to have, an RGB image without the cloud, and this is kind of the purpose here. Okay, so that's why this is not. Of course, there is information, and we want to combine this to do this data fusion to get an image which is cloud-free.
Why not teach it to identify to convert the NIRs to RGBs instead of removing clouds from RGBs, since half the work has already been done? Why use it to remove clouds from RGB photos and instead use it to add features to the infrared photos?
No, so we add information. This is it, all right? So we want to remove cloud from the RGB. Because NIR will see there will be no cloud on the NIR. It only can be, what I expect is can be falsified. Like if the cloud is thick, you don't have the information.
Yeah, sure.
But it gets down to the earth, so you kind of, NIR is basically either without cloud or it's corrupted. I mean, the cloud is too thick and there is no information. So there is no removal from the NIR. What we want to remove from is the RGB. Okay, and then this is just conceptual. So you can, when you see the code, you will see that this generator network is actually defined according to these schemes, so that you have these convolutional and pooling layers, and they are of different sizes, but basically you have I think it's 16, or 1, 2, 3, 4, 5, yeah, 16 different layers organized in this way. But the paper is basically proposing this architecture and assessing how it works. This is the, if you go through the paper, you will say, okay, they proposed this architecture. Actually, it builds on another work where this architecture was proposed, but they extended with this multispectral information which can be fed into the network, and then they show how this behaves. Okay, so you will not see any analysis of the parameters that are trained here or proposed to change anything in the architecture. It's just that they take it and then they apply the techniques to, or apply this system to remove clouds and discuss how good it behaves. Okay. So I have also some. You can if you are interested more, you can read on the convolution layer what exactly it is, how it works, and with some kind of examples how, for example, different types of convolution can be used to identify, make edge detection, sharpen images, or this kind of thing. So this is just the explanation of the procedure or the algorithm. And there are some concepts which are also useful in the context of convolutional neural networks if you want to really go down into the details. But I put it in the appendix, so you can read it if you are interested. And then there is this pooling layer, which basically shows you how from a big, larger array you kind of produce a summary, which is of smaller dimension. And what kind of pooling, basically we have max pooling and average pooling. These are these two types of most commonly used pooling techniques. So if you want, you can read this more yourself. And there is also a nice tutorial. I put the link somewhere here where you can. Okay. Yes. So you can in here. There is a nice web page where you can tutorial where you can read more. Actually, for some figures were taken. Yeah, this figure was taken from here. But then you have maybe more explain everything in more details. You can also, and with kind of nice pictures. So you can, if you want, you can get more understanding of the convolutional neural network, how it works, and how it is used for image analysis. Okay. So this is basically the background that we have for this case study, and what will follow? Well, if you are ready with your installation, you could start running the code and see how all this works. But let's maybe, because now it will be time for a few minutes break. We can take a 10 minutes break, and then we meet and we can see how it goes if we start to run the code and see how to proceed with the case.
Can I ask during the break something?
Yeah. Okay, so let's meet 22.
I also have a question.
I was first. I'm joking. You can ask if it's fast. You can ask if it's fast. I'm okay.
Okay, because I make a mistake. I use a Kanda, didn't use a pep to install this one, and
just run a pip again, like this command.
Okay.
It should be, because that's why I made it this way, because sometimes pip doesn't work, sometimes Kanda doesn't work. So it's not very clear which one. So you have like a shortcut list of which one to use to install the packages. So if this didn't work, just use the other one. Yeah, I mean the one which is in the script.
So if pip doesn't work, use Anaconda.
Yeah, but this was kind of prepared. That's why I use sometimes Conda, sometimes pip, because I don't know why, but it's somehow we spent like 2 weeks just to come up with this list, because it's really, you don't know what is happening. Sometimes, although it's Anaconda 3, But there are these two tools to install packages. Sometimes one works, sometimes the other.
But would we then need to use pip or pip3?
If you have, I think it should be that pip is by default set for the it's like a shortcut to the pip3 if you have Python 3. So it should be like an alias.
Okay.
But you can check. Usually with Conda, Anaconda, it works to just type pip because then it should take somehow for the stuff. So when we were like stuff, we could just type the Conda or pip, and it was taking it directly from Anaconda because you can check it with the which command. So the which pip, it will tell you which one exactly file it is using to install. But for you, I see there's a problem, so you probably need to specify the full path.
I have a question. As I said, I lost the key and I generated a new one, I requested, and they already answered to me, which I was very surprised.
Okay.
Yes, they sent me that. That was you can update your SSH key here.
Okay.
I tried to. We got the first. It was an email where they sent us login and password.
Okay.
I tried to use it. It didn't work. I sent an email with explanation that I couldn't.
You couldn't. Yeah.
They sent me that.
Mm-hmm.
I followed this link. I got this. So it written don't close. I did not.
Uh-huh.
Then, as I understood, I should go to that link.
Yes.
Yes. I came, and now I have that one, but I don't have OTP.
Yes.
I mean,
So it's
a
one-time password.
Yeah, but
Yeah, you didn't stop.
where?
But they provided a password, right? In the email.
You think that?
No.
Password is working in the flow for the few seconds. The problem is they want me to give them the previous password that didn't exist. So this new account
Wow.
with the new password.
So it's a mess for them. But you had the previous email was giving a password, right? Can you check with that one?
You mean
This one.
This one is a normal password, and which one was
This is the new. No, this is the current.
current? This one is like a OTP.
Probably.
Okay, thinking about it.
And then you type your new password and verify.
Okay.
Can I ask you?
Sure.
It also doesn't work.
Yeah, I can show you.
This doesn't work.
Yes. If
And
I
also
use
for you.
Conda,
Yeah,
also
but
work.
I found something here that might be why.
If I use Conda and
If you go up on the other one, it says that you cannot find CMake. Not in this one, but if you go with the
Multi-core TSNE. And this is. But this is pip
this
install.
one, but because I installed this one, I didn't notice this one. But
So but this is with pip, not with Conda, but with pip.
yeah, I'm
yes,
trying
with pip. But this is with pip.
First I tried with pip.
If I install this with the
Yeah,
here,
then
then
this
it
error.
also shows
And
an
on find
arrow.
snake, you try to run some other thing and the same error.
Can you try first install CMake?
Then
Yeah.
I try installing CMake, then before click install CMake, install correctly, the CMake 3.0.
This one?
In CMake, yeah, pip install CMake.
Then I tried again.
And
After installing you got this again, trouble? and the same
And the same as me.
CMake.
So there's no old passport anymore.
CMake.
And it's
then I tried
the new that you generate is on the line for a few seconds.
Okay.
No, it's not
I
written
tried
that it's
this
for 2
one.
seconds. It's written that I just shouldn't.
different and students have different. Yeah, 4 people, 1 type of error.
There's some error.
Yes. Some error.
Did you get a warning message?
Did it work?
No.
With certificate message when you tried?
Why then?
It written that it written that the password is or you entered it is incorrect. But I copy paste already 2 or 3 times.
Maybe you just write them again and say that it doesn't work, and please, like, yeah, give me the exact solution, like working, because this is somewhat strange. They give you this, but you cannot really do anything.
Yes.
I think maybe you try once more to write to them and see. Maybe like say that it doesn't work. Let's see what they maybe, and we can maybe broadcast this to others also.
SSH key, I have to
So
link
what
this
is
SSH key to the account.
Did you have your key now?
No, I just generated a new key with a.
So where are we? Multi-core, right?
Yes.
And when did you do then?
No.
Right now I was doing it now.
Oh, okay.
This didn't
Yeah,
keep.
bash
Okay.
in, bash in Windows now.
Okay.
So
Let's try maybe one more.
Generate keys with that?
you can do everything. I ran
Yeah,
raw
sometimes you
bash.
do.
So
in-
sometimes exit and login back
That's some
works.
works of
I don't know why.
Not like VM, it's like the entire
Yeah,
bash.
log out.
script has been
Yeah, exit
imported as-
and
Maybe double some paths. Maybe.
Yeah.
Okay, I think we have. So
Uh,
you need to
exactly
exit
understand what you're saying?
and log in again.
I have like it's probably
With this.
What are you
putting
using?
this in the also this mail address, but it's HPC Teams is working as well.
Yeah.
App Store and you can just
Oh, okay.
I get the
downloaded from the
response.
download.
Yes, but I just only
Oh, so it's
only
saying that.
the-
Yeah, and then you need to log into the node because without so this is the front end, and from front end you get access to the computational node. So this is with this command.
It's similar to having written machines only console.
yes, maybe we can
This entirely
Every time we across this, we need to use this every time.
Yes, or I will explain what this is every time because it's like front end, and the front end is used to reserve computational nodes where you can run the code. And then no, this is already. So I think you can just continue with the one which stops.
Now I don't want to install Anaconda in this. I'm thinking, will there be a problem?
Okay.
Oh, okay.
Okay, so maybe we can say that after this we didn't realize, but somehow for staff it works automatically, but since for students not. So after installing, where do I have this? Let me just tell you. Here. After you run this installation of Anaconda, please log out and log in again. And then the command should work. Since there is a problem with some paths, they need to be updated. So you need to log out from your bash, from the HPC, and log in again, then they will be updated. We didn't have the problem. Maybe, I don't know, maybe the staff has some different configuration. But it seems that for students, you have to log out and then log in again. Then the paths are updated, and then you can. It seems that then it works. I will update the script so that all the information is. Probably it's also why this you had to put. Probably now Conda and
it works.
yeah, exactly. So once you log in and log out and log in again, then you can just continue with Conda and keep without this because some paths were not updated.
So when you install Conda, it says to close this shell and open another one, but I don't know if we can close the shell without exiting.
Or you could yeah, it's better just to exit.
Yeah.
You probably, if you type bash, it will on top of that open a new one. But
Okay.
I am not sure.
Not best,
And
yeah.
maybe it's better just log out and log in,
Okay.
then it works. So did it work?
Yes.
Okay. So now it's
Continue with
so we can now continue with the code.
Yes.
Okay. So good. So then we have the solution. How? Okay, so if this is okay, we'll get also explain because we reserve the node for 1.5 hours. So after the time, so I can maybe quickly also explain this part. So with this srun, you put the time limit. So you ask for a computational node for this amount of time. So after this time, it will just quit whatever job you have. And that's the code. So you basically need to restart, run the command again and ask for another node and you can put 3 hours. It's just that if you put too much time, you will be put on a long waiting list.
So I should start from the beginning?
No. Just from the last command. What is called this? Just log in again. Just close the window.
I think it was a problem from their end because they refreshed my password.
Okay.
And then
So it works out for you or not? Or you're waiting?
So again, you put stick.
I'm in the system, yeah. It works for me.
This one.
Yeah, I told them I changed my laptop and I want to update my key. So they sent me the link where I can update my key. So once I updated my key, I have access. So
Well, they did it for me, but
You can log it.
I cannot. It give me an error. Which kind of message? Or can you show me what did they send you? The link and after you should log in somewhere.
Just that.
we went to a place.
This is. Oh, you have the terminal, so you can just type the.
Oh, the same guy.
Like before you log in, so you're not using put.
She is on duty. So they'll give the password like this. This is a link.
Now we've lost it.
This
So
is
how
where you
did
go.
you log
But
in
it
to
doesn't,
the
for me,
SSD,
it
the
does it
HPC
OTP.
before?
I have also
Just
this.
copy
No, you can ask.
I don't have this old passport from the first, the second.
Do you have a password?
No.
No, for me they send
but
not
from
like
the
that.
lecture notes.
For me they send something and it request OTP.
If you go to the top, I think you can.
Can you check this one?
Just, I got a new email from another
You need
guy
to
that
log
needs
into the HPC. And you replace
Email is all valid.
Okay, and then you replace username with your HPC. Okay.
This means this is the command.
So you can type your login.
What?
But I already have an account. So do I? Okay, so I'm downloading.
This is the HPC. It's the first
Is it in my PC or in their tab? Now I'm inside. So now I'm not doing anything on my PC.
You are connected to the computer in HPC.
Yeah.
And you have like some place there.
Okay. Okay. And now you can reserve the new node again.
So this
you
just
go to the file.
saving the link, right?
You can use this one.
This is saving the link.
And again for 1.5 hours. That's
Yeah.
just 2 hours.
Then permission.
Okay. And now you can run the command which failed the last mission. So this was torch. Okay. Okay. Let's see. So, who is done with the full installation? Anybody?
Yeah, I'm copying the zip.
The zip.
Yeah.
Okay. Yeah, because once we have the zip, we can show you we can run the code.
I cannot install the multi-core TSNE and I cannot get the zip file.
A zip file is on Moodle.
Yes.
So you need to download it
It's
from
in my
Moodle.
PC, right?
But for maybe first, let's go through this multi-code. Did you log out and log in again?
No, you are in.
And if you type this command, what does it say?
So there's a
You have to install CMake first. This is one other thing. CMake.
Oh yeah, this maybe I should immediately. So please, before multi-core TSME, I have to read. Okay, I will just update this.
So what I'm running is I'm running the Ubuntu bash on our Windows. So yeah, so this is actually Ubuntu, but as you can
Please. Before multi-core TSME, install CMake. So
you can have
CMake goes before
you can use the normal
multi-core TSME. We change the order,
No,
but I will
initially
doesn't
have
help.
like this entire thing. No, that I will have to set up in your
But
computer.
it's done.
Right now it will not work on.
You have to. So it's done. It basically doesn't.
Creating it.
It's a problem.
Because for me, like when I type,
Ah.
I'll show you that.
This is killed.
So this is the normal command. This is Windows. So for me, if I type Ubuntu, it belongs to Ubuntu. So now I can use Ubuntu bash.
And this is torch.
So to set this one, I have to go and set it. Then you can use Ubuntu.
Can you please show me how did you do that? Because they
That's
said
really
already
like
4 times and it doesn't work. I mean,
Yeah, you get something like this, and they give you the first
I can give
Download
one.
the file from Ubuntu, and then
I
uncopy.
can give one.
To put
Yes.
exactly.
Yeah, but you have to do something before. Yeah, like this. Yeah, you can see here. So you can do it.
Yeah.
You have to open another terminal page.
The password expired, so have to put the current passport is the old passport and the OTP
And
is
then
one.
now you have to like use CD,
So just put it
change
like
your
password.
query, and
Then
like
password, you just set
Yeah,
this
yeah.
password. Because this is
Yeah.
only to start. So you
for
set
the
password.
last, and you have to go
In this place,
easier.
current passport is
Go to the file,
Do you have
new
one?
one.
I cannot listen to
Desktop.
people.
Do you have old password?
Yeah.
Just put it.
Sorry.
I can
Can I ask?
I can
Did you manage to install Torch
Yes,
without any?
problem. Yeah.
Because now we get that it doesn't download to the end. It ends up at 99% and then stops.
I'll check, but I'm pretty sure.
If you could just see the download progress bar.
Yes, I'll see the torch. Torch Vision.
Set a new
So
password.
this torch. This
But
torch.
then the start was a new password.
Yeah.
Because we have now maybe there is some.
They should have sent. You have to work quickly.
So basically you have to, in your
You have to work really quickly.
It should be.
you have to you have to
Run with
Yes, but now it's
like
expired.
you are
Now it's
here
expired.
and uses the
This one.
you have to go
You have to
where your file is. So you use
My case is the
CD.
problem because I don't have any current password because
Do you know
I was
which
second
of this
the new account?
You have this.
No,
CD?
I'm just working on my
Right.
own account. They got my old account, but
Yeah,
now the problem is I don't get all the password.
Yes.
Then should
And
I
it's
There's
just
some step.
That's
It's
gonna
also rolling.
be on the my second name?
Can we go back to?
Yeah, but he said we need to use Anaconda.
Did you send an email to them?
Yeah, my
Because
account
something with password.
is order,
And after that, it should work, but it doesn't work. So.
Okay,
Try to
so
put some
you are in
lights.
the right place. And then now you have to
So
use this
what
command.
did they
In the second mail,
understand what it
they
is
always
all
give you the
username.
name, username.
This
This is the second mail. But now they send
Oh,
some
meeting folder, no,
the rest
no,
something
meeting
like
folder
this.
is in the
It's short.
You don't have
I don't have the
folder is
password.
here in the system.
But you also did you answer the one that I don't have?
Yeah, but there's only that give me again the same story. You know?
But it's exactly what they do
Yeah.
for me.
You don't
Yes,
provide
it's
your
there.
new,
That's
I
right.
think
Yeah.
your old credentials.
Yeah. Okay, don't worry. I'll try to ask him again.
Yeah, but
Yeah.
Everyone has access to the same sheet as so everyone is
Yeah, so you need
So this is the key we need to provide them. Yes.
we are
No, I think it's just.
Could you install the multi
Do they
whatever
explain what
whatever?
to copy with this?
yes, but
Yeah,
we
yeah.
install first install Snake,
Yeah, yeah.
same
exit,
account works on this, you know.
click exit, then you have to re-enter
So make sure that you
the
copy
the thing,
This one, yeah.
and then it should work.
just execute.
Okay, this is magic, I don't know. I mean, I run it Anaconda 3, basically asked for the exact path, and it worked. So,
Yeah, now you go there. Here,
this is very strange. So,
Is IP8?
Yeah,
try
yeah.
always with this Anaconda 3 beam and Conda and install. I will put it in there. I don't know what what is not going on. This is the tricky one because it seems every computer doesn't want APC. You have
so
similar
I'll do this myself because I was just telling you, but
Something
still,
goes
yeah, it's okay.
So just continue. I think it's good if we get this environment installed today for as many photos of you as possible. So which one now? No, this. Which one is it? The next one, right?
Yeah.
This is no, third vision. Try with this other
Will it
one.
work?
So
The migration one, then.
Yeah, weird.
Okay. Should we start again at the top?
This one.
How much of it have we done? So we have this open. Somewhere.
Yes,
Let's see.
So I did step 1, 2, 3, 4, 5, and now I was stuck at step 6, and also step 7. Well, I could make it directly, but step 8 I couldn't do.
Okay. So yeah, please use
Yeah,
this.
yeah, it happened to me 6 times, but then after it worked. Okay, so we just copy your password and keep it.
So I suggest we add the contact bit
some errors,
to
No.
Previously. So you need to probably reinstall, or at least those which you see the error. Well, maybe it's not a problem because it will tell you once we run the code, it will tell you what is missing, then you will know what to do the install.
so I shouldn't.
Please don't.
I will try the.
Can you disconnect again?
So Ajay,
Yes.
if you identify
For me,
bash or something or anything like this, path to contact.
No, I didn't.
Really?
Well, usually what works is to log out and log in again.
I believe in this method.
So then you just use the full path, Anaconda pip install.
That was working for installing all packages except the multi-core TSP, because it is looking for pip. Pip is not installed.
But pip is in the Conda. So you can use Anaconda bin pip.
Yes, the new password. I do this, but internally,
So in fact, it says
looking for
CMake
pip
that it
again.
has a problem with.
So something.
You can find CMake.
So you can install CMake first.
I did.
It is
And you did.
installed through pip, yes.
And then,
Right,
so
CMake.
maybe if you log out and log in again,
If you try logging in, that's more.
because it seems that for some it works directly. I mean, you log in, you log out, and then it loads the path, and then it's okay. But it seems that every HPC account is somehow different. I don't know why. And you need to run it on the node.
Okay.
If you don't run it on the, this is important. You have to allocate a node. If you run it from the front end, it will not work.
Yes, this is what's happening.
Because front end is, you see the message, they never run any programs on front end. So front end by HPC is blocked from, you cannot compile stuff, you cannot, even they have some commands, they don't allow you to run. You have to allocate a node on the HPC. So if you want to understand HPC more, you should consult the web page and like on the architecture, because I can quickly just explain this. You need to.
You've done this already.
Yeah. Print screen.
Which one was it?
Core TF.
Send a print screen of this that when I enter the password this happens.
Okay, so I just want you to pay attention to this highlighted line. This is important. So when you do the installation, please always first, when you get access to the front end, after doing SSH, you need to allocate a node. So it's like the front end is just to do basically file manipulation. You cannot even compile, you cannot run programs. So you need to do this srun, which will give you access to a fully operational, let's say, environment and CPU, which allows you to make installation of the. Exactly. It's like you are on a new computer, basically. Yep.
At each session, you need to redo this.
Exactly. There will be one change to that when we ask the training of the network. For training of the network, we'll ask a node with GPU because it will not work on a normal node, and this allocation may take some time. So you may need to wait hours to get access to a node with GPU, but this we have no control over. This is the HPC scheduling, and that's all. But this is for the last step once you want to run the training.
Okay, sorry.
Okay, so did it work?
Should I install
Without this one, yeah. Okay, so you are basically. Yeah.
The program?
Okay, anything else? Q5. Again, okay. I will update that.
No,
You can just put another way to do it.
I want to.
It's calm down.
I know it's not my fault, but I want to scream and kill someone.
Me as well.
Does it work for you also?
No.
Which stack? Which stack you have?
Step 6.
C. But you
CH1?
So may I just ask who has managed to install everything?
Yeah.
1, 2, and almost, I guess, almost here. 3. Okay. This Kona is taking then so then you just make the folder doesn't work. So make it here.
Yeah, he got an answer question too.
And then yes,
To
it's in the HPC. On the HPC.
Here it says it doesn't work. You need to update. Here it says
I have to answer yes.
Are you running it as administrator?
I can't because I don't have the admin password.
So can't you find that?
Because it's not my code. I'm not running this
I
on my
forgot,
laptop.
I don't have key.
So hey,
Yeah.
another
Another one, yeah.
Okay, so then you can make dear.
Normally yes. Now it's in the I just have to
You connect to the server.
Yes, that should,
Here I have Linux.
Yeah, because you have new computers.
What do you
Because it's better.
Yes, they send me answer, but it doesn't work.
So it doesn't work.
No, because they send me the password
Uh-huh.
again already like this time, but it doesn't work. I send again email.
Otherwise, one to Linux from my camera. You can create this virtual Windows environments.
For Google it worked.
For me, it's not working as well.
It doesn't work. The same has the same.
And the same procedure.
Yes.
The
Yes.
same
They
procedure.
send
The ones
us-
where it's a mess. Yeah.
Maybe I was now
Maybe
I'm
can you
just
retry?
like
Just try us. It seems that this is like automatic reply. Like no, or they write some.
No, they write if I ask question. For example,
okay.
I mean, it's two guys
Mhm.
or girls, I don't know, were answering to me. But,
They are placed here, right, in this building.
I don't know.
HPC.
HPC.
We just go to them. Let's go.
Yes, with laptop.
Yeah. But I will check if HPC.
I go to play.
I think they are here.
How can I put the OTP?
Oh, okay.
They send it to me.
Yeah,
They send it.
You still play
They send it to me.
It's working.
the server?
European.
Which one?
Who is the guy?
Emmanuel or
Kiefer.
Yeah.
Yes, he's here. 4-4.
4-4.
Yeah, you see here.
Maison du Nombre. Oh
Is
yeah.
this? So you can maybe he's okay. Maybe you still can. Or ask
Natalia, we go together.
And we can go.
Because if you send emails and they cannot solve it, I think you just go there.
Yeah.
Ask them to fix it for you.
Now?
Yeah.
Okay.
So 0.
Because anyway, you cannot. If you go in 5 minutes, you can wait and
We can go together if you want.
Okay.
Changes, maybe you can go with them and.
Okay.
Look at that and say, yeah, look here.
Thank
I think it's fastest this way. I mean, that's. The,
Yes, because
Okay,
If they
we are
don't-
going there.
That's what you have done.
What is your,
4-4. Office 060. 445 060.
Oh my gosh.
I think it's best to
It's on the way.
It's done.
Even if you open in again. I did it already.
Make there is the
And
command to make
try to install it again.
in the space after space.
Yeah.
And then now. So now you can see it's out of the And now what you need to do is to just download from Moodle. You download the zip file and you have it. Okay. So then
If I run this,
the whole zip file.
Just to write out.
No, so please zip it again. We need a update this zip file. The archive.
and that's go back and install it.
Yes.
you
So you can just
So yeah, it
we need
shouldn't be
to
an
copy
issue.
this one.
What if you go to an Ronde,
So then you go to
CD
your
Ronde,
No, this way it will not work.
and what's
You
the
just remember where it
No,
has it.
that's
And then you go to the terminal
where
where you access HPC.
Yeah, point here. No, dot C. No, sorry, it's a dot and slash. Dot slash.
I think yeah, that is your yeah, that is.
No, try easy.
So
Put install first.
Yeah,
Go for the
run it.
autocorrect.
No, just
Okay.
just run the. What I need, you need to run the terminal.
No, take this one. No, what we don't have.
Yeah.
Exactly. Yeah. So this one. So now you just need to log out from here. So exit. No, just exit.
I cannot get to work. And this command.
Yeah. Okay. And exit again because now you are at the front end.
Do you try it?
You left the computation or now you're into the front end. And then maybe. Yes, perfect.
Okay, there
so now you just
then
copy your command. So
okay,
you
is okay.
you need to go to the folder where you have your zip file. So you can copy this path.
No, I should paste my file here.
No file. Just the path to the file.
Okay, and now.
So the folder where is it? Here. So you can copy this. If you click on this, yes, you can just copy this.
What?
You can just take this desktop.
You can.
Yeah.
And then we go here.
Put conda.
So this is
conda install
one on top, and I think.
Oh, what about class?
You can paste.
So this
Go to the other
a
one.
few hours or weeks.
Go to the PDF file.
You didn't copy.
That's better.
I'm starting to for the final thing.
Okay.
Like this
Yeah, information.
Now everything I want to install
CubeSat.
Even information. This is on the road.
This is information. We can read it.
You see, it was installed probably. Because now the phone page will be installed.
What is that?
The packages have the conversion, not the same as the tickets, so you cannot use them interchangeably.
Yeah.
So actually I use them
Maybe, yeah. Can you copy to call?
Otherwise it will not work.
That would be the easiest.
Now it's done. So now
This PC.
What happened? They removed the time.
Yeah, I also remember you need to access it from there.
Yeah, but they removed the timetable now.
Yes, yes.
You can always claim ignorance.
But you can just make it have text.
It's okay if you put it here with
I made my arrangements with the assumption that I would not pass on
I think I had
Most universities have days off. Either this week or
Okay,
next week.
and then we go to the
And so the
and then you can use
case for us.
I think it was
yeah, try to exit.
this 01, this is your slide. And then you can now see the
I was thinking about
now it's in many places. And then Spain. Okay, you can just. So we need to put some CD. Change the CD first. And then just remember the space. Space CD. And I think if you type the beginning, you can type the spec. Yeah, and an I. Okay. This, and then
rather than generate
informatics with capital I, and then it will complete it for you. Yes, and then you should see the file. Yes, and then you can just copy the command.
Possible.
So it was in the when you
file
with the one with the list of and run you can just copy it.
but no, it's not that.
Yeah, it's a small one, right? Like you add
No,
more
but
and then
it's
it
not
expands
that.
and then you like it.
Yeah.
And just
It's the
replace.
same. It's like this. It's really nice, you know.
Expand it to.
Just replace
So it's
this.
about like it's about
No, it's not. You have to look where you download. You download
yeah, I know. It's like
Because everybody has a different.
You do this file.
Yeah.
this thing will expand like snake, you know. It becomes.
Well, I want to download it. No, you have to. This is to copy. You have to
Yeah,
download
initially
first.
desiccated.
Where do you get
So
it?
when you add
From
more, it
Moodle.
expands.
You enter in Moodle in your PC normally and download the file.
Yes, it is a direct option.
They give it to us from.
It's a zip. It's a zip file.
The first time I was confused when you're supposed to keep it.
Drones are shooting the whole servers.
Yes. So then you open a new terminal in Windows. Yeah, can we put it?
It's good.
Okay, so there's no.
Okay.
No, it's a local. We need a local,
The whole G
not
generation and
a local shell.
So we wait a few minutes and
Yes and no, because you have to copy from there to the.
Yeah, did you do the copy of it?
So now you
Yeah.
copy it.
You copy
Right?
it?
So then you go to HPC, log
I've
on
done
to
it,
HPC,
but you have to do it from your local machine.
From the phone.
You have to open a shell in your local machine, not on the HPC.
I
Then
opened that. Yeah.
you navigate.
And
But
then,
then,
because I copied, so you now see this file
See
here.
what he's doing.
We
in
need to
I mean,
move it to
understand.
the MC gun because I do some errors. I copied it
Generate
to the main folder. Sorry,
computer.
I'm touching.
But you cannot run the SSH command from that shell, right?
So you do need to move.
But if we don't find the SSH
MC gun.
Yeah, exactly.
And
It has no point.
What will not find?
But we can copy the key from there. Can we export anything from there to here?
Oh, but the key is not open. The key is in the.
In the Ubuntu path.
Okay, I will name it. This is the right name because otherwise the script will
It
not
doesn't
work.
find the location of
And
the
then you
key,
move
so we
it.
don't know where to put the
This
location.
section is.
To this folder.
But here I have a for
Yeah, so if you just copy the command there,
With
with your username,
take benefit.
you just copy the user to your username, then you copy from the local machine to the server.
Will it work?
For me it works.
For him it should not work.
Yeah, for him shouldn't.
Yeah, that's up to you. Here, and then we have this, and then we
And it
put
works.
MC.
No, then I.
Because you don't have the key.
Yeah.
Okay, now you
How did you do?
Because I have.
Because
Yeah,
I
I have
Because I
the
have.
key. Yeah. But where do you have your key? Where is your key?
the hard drive.
Oh, it doesn't find the key.
But I didn't know where to enter. Where I can put it. So the only thing would be. Oh, of course.
Yeah, it's working. It's working. There are a lot of. Okay, so you are now ready with the.
But they read it wrong.
Then you can also help others.
Here we are.
Check everyone.
Sorry, we're just going next door to discuss it. Yes.
So we have a few done. So I think next week we will.
This is too late to check
Those are essential, but the problem is you see with problems.
And I think we don't win it.
A lot of people are not here because it's the midterm. This is a traditional week in France and Germany for holidays.
Next week.
This week.
Yeah, this is.
So we have low classes today, we had low classes yesterday and other courses as well.
I see.
They're going to come back and they're not going to have anything running, and we're going to spend the next session getting the other half of the class. Which means that we don't get the project done. So
Because it's somehow individual, really, like depends on the.
yes, but
We have to.
it's individual, but there can be a certain amount of in-class time just sharing machines.
How to transfer. That's because if we already have some installed,
So how many are installed?
How many? Like 1, 2, 3, 4.
Yeah.
Okay.
So, and probably maybe you also can help those who were here today but didn't get it installed because of this private key issue. So then maybe you also can have it. Maybe you could also, if you want, you can also come to my office like during the week, and I can help you with this installation. Maybe if you can, so that we get as much as possible. So if you, whenever you have time, you can write me an email. And if you have problems, you can come and we can do it individually, let's say, so that we have as many computers ready for next week as possible. Okay? So
this is really critical.
Yeah. So that's.
We have an emergency. Well, not emergency. This would be dramatic. We have a spare session which is next week, which was to mitigate any problems this week.
This week.
So we're going to use that for doing the main material now. But if we spend any of that time, like even in a minute on installing, then we're not going to finish this. So please make sure before you come that you can go through all these steps.
Yeah, but it's, I'm trying to help here, but it's getting some problem that I've tried everything that I've done and it doesn't work still. It's still with that multi-core TS.
With this one?
Yeah.
But try.
It's inside mount. No, sorry.
So you, but did you try also with Anaconda Bean Bib?
Yeah.
And what does it say?
It's a big, huge error message.
It's CMake still.
But it's the CMake still,
still there.
And if I use Conda to install CMake, it doesn't work. If I try to, I can install CMake with Conda, but then I cannot use Conda, neither pip, to install the multi-core.
So what I would propose, you remove your Anaconda 3 folder and you try from scratch, but this time you always use, so what you can do,
I use this all the time.
Yeah, but you do the from scratch. So uninstall Anaconda, like remove the folder, reinstall it again. After installation you log out, log in again, and then you always, as you did, you follow these commands, full path commands, and install CMake before multi-TSNE. Let's maybe, still you can try this. So, because I think there is now some mess, so it's better to just remove and start from scratch. It will be faster probably. Because it worked for you basically, so let's hope that...
What about for you it worked? Did you solve all the things?
Everything worked, but then instead of installing CMake later, I installed CMake
before TSN.
Yes.
Yeah. This I will update the file so that you install it before.
I took care of the order.
Yeah. So I will update the file so that also with this logout information, so that you can once you do the fresh installation, you have all this there. So let's see. So I can maybe just quickly tell you, so we went through the background. What is kind of, we didn't do actually, is to run some of the commands which actually allows you to generate to train the network.
Okay.
Now it's working.
But these are basically commands that you can, once you have the installation, you can try it yourself basically. So you can just type the commands one by one, and it would basically generate something which is in fact already in the zip file that I have provided to you. But what you could maybe do now, those who have already everything installed, you can go to this make dataset folder, so that just some of you know what to. You can go there, and basically execute this command. Let's see if this works. So the Python crop RGB NIR and apply this connector. So this is the command which actually, and this I can show you what will happen, is that you have an image, quite big image of Luxembourg area in the image folder, in this make dataset EMG folder, and this command will split it or crop it into smaller images. So then you have a folder which is called RN, and in this folder RN you will have two files, two subfolders, RGB and NIR, which will contain these RGB and NIR files if you run this command.
Where exactly it should be a picture?
The picture is in the, but it's on the HPC. But okay, if you have your zip, if you unzip this on your local computer, you can view this file. But for this you need, okay, I can show you. So if you unzip it,
Dave, were you able to locate your file from OpenTree?
and no, in the make data
So
set
it's /mount mnt
image,
/mnt/c.
and then
This into the Windows
okay,
drive.
yeah, not this is because this image is GOT file, so it is like extended. It has additional information.
From
You
the
can try to
Windows
open it
drive,
in your standard,
I have from Windows.
but it might
I'm
not
all
work.
Windows right now.
Yeah.
Yeah, it will not work. So to see it, you have to use the, for example, Fiji. I put it here, but this we need to.
Using
This one is Fiji. There is a link.
Okay.
You can find a viewer which can show you if you install this software, then you can use it to view the image, because it has like more. It's not RGB. It's more. There's 8 channels.
In the sense that you just state where you put false, context false, on states.
It needs a license?
No, just to register.
What does this result mean? Is music found this?
This is fine. This is so now in the RN RGB you have 210 images which are cropped images of the. I can show you so that you know what locally what is happening. Let me just so if you use this Fiji. Where is it?
So, so I just reached the 9th step. After that, what do I do?
9th step is.
I mean the final step of unzipping all the files and.
Yes. So what you can do now is to run this command. So you can go now to the lecture notes, and there is this section on training the multispectral conditional guns. And then you basically run this highlighted. First you go to the make dataset folder
inside
the on the HPC. So you can execute
my gun
MC gun, and make dataset. Yeah. And from that folder you run this command. This is working.
Make dataset.
Yeah, and then you can run this from the down. You copy this Python.
We start dataset generation.
Yeah. So you basically prepare the data for training. Okay, so you can just run it. Okay, so I will just explain what this command does. Like, locally because you cannot see it on the HPC. You will have to download it to your local computer to open it. But I have done it already, so I can show you what. Okay. So, okay, I am not sure you can maybe see it very well because this PG displays it, but it's quite dark. But this is a image of part of an area over Luxembourg. I'm not sure you can. This is quite dark. You probably need to see on your screen how this looks like. Because here you can see some.
Where is that file?
In the make dataset image.
Oh, inside this.
It's an inside image, IMG.
Okay.
You have the full image, which is has many like it's like a high resolution image, and you can see it's like 3,000 by 4,000 pixels.
Yeah.
Can we open this on our computers? No.
You cannot, because you would have to download this image to your local computer from the. That's why I'm showing you here. Also, the problem is that this image has many channels, so it's not only RGB, but it has eight different channels, and it looks a little bit dark. But what I will show you in a moment is if you use the if you go to the. I mean, once you have run this Python crop RGB NIR script, what it does is takes this image and cuts it into smaller images, and the result is in the RN folder. So if you go to, okay, I have a different structure here, but basically once you go to NR, you will see two subfolders, NIR and RGB, and in the RGB you will see these kind of small images which are basically cuts of the big image. So you have 210 images, and maybe this one is dark, and this one is a bit lighter. So what it does, it basically cuts this big image into this. The script cuts it into these smaller images, and then the next part, basically on top of this is, so we have, this is used to chop this big image into these smaller 200, in this case 210 images. And then what happens is that we have to generate clouds. So the idea with this project is that we don't have actual clouded images. We have, because we are using it for training, so we need to have a good we have to have good quality images. And what we are going to do, so we are going to have, this is what you obtain when you do the cutting. Okay, this is from the paper, but this is the idea. So you have an image which is cropped from this big one, and then on this image we will generate, there is an algorithm for generating artificial clouds, yeah, but they kind of look reasonable. So what is done, we are generating clouds, and in fact I have the command in the lecture notes, but we are not going to run it because it takes a long time. So in the make dataset clouds subfolder, you have 300 generated clouds already. And you can, if you download them, you can view them, basically. So you have the clouds, and then what the training does, it will apply the cloud to the image, so it will merge it, and then you give it for the training. Okay, so this is basically the idea. So the clouds, this is the, so we have, like you have already cropped the image, so you have these sampled images, 200 images. This is just for make training data list. I will explain a bit more, but not too much on that. So this is just to have the same in the project. What they do, they basically want to have. They want to have kind of a uniform sampling, so that we use uniform, like images of the same type for training, sampled uniformly. So that you have, let's say, same amount of forest, same amount of water, same amount of cities, so that these images are not over, like, for example, forest is quite common. If you take this kind of big picture, forest will be, if you take Luxembourg, quite frequently. So there is a chance that you overtrain your network for forest type. So this is kind of a way to overcome the problem. So, but this is also done for you. So I already prepared this, so you don't really need to bother about this part. And then what comes to for generation, you need to, and this we will also see next week, you configure your training, and this is maybe this is already also done for you in the configs folder, but this I can explain more. There actually you specify what is your training data, so you provide files, paths to these images that are used for training, and you also provide like batch size and where it is a generator, what is the discriminator. This we can look in more details later, like next week maybe, and then, or maybe even today if we have time, and then we can actually will run the training of the network. So you will see how this works. So this is just the overview of what is done in the, like once you have the environment, these few commands basically let you train your network, okay? And we will...
I've got a general question about the concept. In cases where the image is completely obstructed, the ground is completely obstructed by clouds, what can machine learning do when there's no information for it to work with?
If there is no information, there is not much. It can basically generate something which is maybe would look like reasonable terrain, but it's completely not related to.
So it's only for partially obstructed.
Yes. So I mean, of course, there has to be some true information. When you can restore things, and you will see it. Like I have another, because these I'm just telling you the commands how to run it. But I want to look into some particularities of the code next week, and then we will see how the thickness of the clouds, for example, changes the reconstruction. So if the cloud is less thick, you can see that the reconstruction is quite good and corresponds to the original image. But if it's not, it will generate something which looks good in general, but it's not related. I mean, it's different from what you see in the original image.
So, for example, if there's a big cloud is above a house and around this forest, it will maybe just
generate a forest. Or, of course, it has also this NIR data, but if the NIR data is not exact because the cloud is thick, then it will be some kind of something which is maybe if you look at the first time, it looks reasonable, but if you look carefully and you compare, you will see that this is different. Exactly. But we still have like half an hour, so let's maybe still go a little bit in more detail. So
one question for when we run this, we generate all these files, all these images here. Are we like, since we cannot open them because they are in the server there? Are we supposed to do anything with them? Like after we run this code?
After we run it, we download the files. We can download, and then we can locally run some kind of analysis. And locally, so for like analyzing let's say the code locally, it's maybe good to install also like Anaconda on your computers.
Yes.
And then some of the libraries, like also like you have it locally on your machine. So you could try to also have the same copy so that you can run. But of course, you will not install QPy because you don't have GPU. So this is not needed. And multi-TSNE is also not needed, so these things are not necessary to see. But I can show you. Just
No.
Okay.
If
because for example, like I generate the first part of the code, which is converted from RGB to.
you got this cropped,
And then the cloud part, which is the subsequent one, it adds clouds to this same, files? Because I did not.
No, it will generate clouds in the clouds subfolder.
Oh, okay.
Oh,
it's normal.
clouds. Okay.
So and you don't have to run it because you actually already have the clouds.
Oh, I
there.
have them. Okay.
Yeah. So you can see the clouds there.
Yeah. A lot of files.
Like 300. Yeah. And so I can also look at this. Maybe it's a good idea.
Can you
Okay, don't worry.
So if you want then to run it locally on your computers when it is ready, what I would propose that you install Anaconda 3 also on your local machines, and you can install also this chainer, basically. That should be, because this will be provided, so we don't need this, and yeah, basically chainer.
I try to run the.
But this is once you have trained the network to download.
No, but it's okay because we already had to install this for this last homework. We also use chainer.
Right,
Yeah,
right. So it
it's
should
already-
be, yeah. That's already there. So I think nothing more than that is needed. So you have it already. And I can maybe, what I want to show you then is that we have this, so then once you have this cropped image, which is in Aran, then the cloud will be put on top of that. And this is done, so there is the training part, the iterator, which we have seen last week. What it does, it will take an image from the images provided in this RN folder, and it will combine. So it will use an original RGB image. It will randomly choose a cloud and put on top of that one. So this is like a randomly chosen cloud image. This is the chosen for training image, and combined. And then this image, together with the NIR corresponding NIR information, is given to the network, and then the network is to the generator, and the generator is producing the cloud-free image. And this is basically done here, so you can see the result. Maybe it's not visible on this screen, but once you have it on your computers locally, you can assess where the cloud was and compare with the original image and see how well the network performed the task. And what I will, so this is in this cloud removal zip folder that you have also on Moodle. And here I basically extracted parts of the code from the whole the implementation, and actually we don't need more than that, so we will just look at this part of the code. So I will explain how the images are merged, so how this original RGB image is merged with a randomly chosen cloud to produce this clouded RGB image, and then how can we generate such images and provide to a trained generator to do the cloud removal. And this is basically done in here. So basically what we do, once we have the network trained, so when you run it on the HPC, what happens is this. Actually, this is already provided for you. This trained by pre-trained network. So what you do, you basically take the generator, you initialize the class. So this is some standard parameters that they use. And then you load a file which contains all the trained parameters. So once you have loaded, then you can apply it. So you take basically an image which has this clouded image with NIR information, and this information is then this is given as input to the generator, which produces the output. So this is quite easy. Then once you have trained it, you basically instantiate your generator, load the parameters, and then you can provide a clouded image, apply the generator to it, and then as an output you get the image which is supposed to be cloud-free. And there is a small number of transformations, but these transformations are just, we don't really need to care about them, we just need to apply them because the network does this kind of transformation. So we kind of revert it to get back an image, and then we can simply view the image, which looks like this. Then it is without the cloud. So this one we can see. And then this. So the first part we are going through next week is to explain a little bit more how this code works. But then finally, what actually you can use for the later is just this part of code where you can use already the NIR RGB cloud class, which does everything. So the code is kind of explaining what is behind this class, but then you can just basically provide the images for cloud that you want to remove the clouds from, and then you can take which example. So this is a list of images, and then you say which image from this list you want to remove the cloud from, and then you can basically plot it. And so then you see that you have this clouded image, you have the NIR information, and then you apply the trained network, and then you see, okay, this is the image with removed cloud, this is the cloud. And then if you open the original file, you can then compare what is the restored image compared to the original image that you have in the folder. And I can show you here. So this is the one which was with cloud removed. And let me just see, so which, because I'm printing this out. So this is image, sorry, I just find it out. It's here. So we were getting, okay, I can tell you for the moment, you don't need to worry about this. This is image number 3. So I can zoom it in. So you can see this is the original. Okay. This is the original image. Oh, probably, do you see it? Well, maybe not all the details, but this is the original image, which on top of which we put the cloud, and then we ask the trained network to remove the cloud, and then you can compare. Of course, the colors are a little bit transformed because we apply color correction, but otherwise, what is important is to look at the structures of these like roads and land, and then you can see that actually for this cloud, it did quite a good job.
Do you have up there also the image with the clouds on top of this?
Yes. So this one you can see here. So you can see where actually the cloud was present. Here it was that, okay, the thickest cloud was kind of here, so it would correspond to this area.
Oh, okay.
And let's see. So there you can see some difference.
Yeah.
It's not, I mean, it is not exactly, I mean, it looks reasonable, but if you compare, you will see that where the cloud is thickest, you see some discrepancies.
Yeah, because the cloud there, it's like, well, it's more or less like transparent if you go up.
Yeah, exactly.
Yeah, okay.
And then of course you have this NIR information, but this NIR is kind of not good.
Yeah, because even with the clouds, you can still see some of this structure.
Yeah, exactly.
Some of this structure. Okay.
Yeah. So where the cloud is thin, you can actually do nice reconstruction, and where you don't have the, I mean, when the cloud is thick, then maybe the reconstruction is okay, it's reasonable, but you are missing some part. So what we want to also go through is to go through the whole, let's say, case study and show you these most important parts. And actually, for you, if you want to already to read a little bit the, let me see.
Are you going to do it to real image?
Yeah, so these are, we can do to a real image. We'll take images which we have. These are like real images. The big one is the real image from a satellite. And let me just show you one thing.
Does having images of high resolution make it easier or harder for the algorithm?
Higher resolution, I mean, in general, higher resolution means that you don't put the full image. That's why we do kind of the cropping. Of course, if it's a huge image, that will take much more time, and your network has to be much larger, because we kind of specify the input to these cropped images, because this is like a case study for smaller images. But already these images are quite, I mean, you cannot really put the full image, whole image, because the whole image is very diverse. You have usually land, water, cities, so it's best to kind of crop it, restore, and then put it together. And let me just check one thing. So,
also, do you mind if I leave 10 minutes earlier? Okay.
Yeah.
I would normally do this, sorry.
Okay. So I can just tell you. So this is this is what you have on your HPC basically. So we are not actually using all the files which are here, and I don't even want you to maybe look that into. I mean, if you want, of course, you can try to read this code, but this is a little bit involved and complicated. And for example, you have these two files in the main folder, which only differ the fact that you can use multi-processing. So you have multi-CPUs, you use this file. If you have one CPU, you use this one. So we will look only on this file. And if you open, this is basically your starting point. If you open this file, what you will see here is basically what we have seen last week. So although the structure of the network is very different, it's a convolutional neural network, what you will see is the same workflow. So you construct your model. Okay, you say go to GPU. That's why you cannot run the training on your laptops, because you don't have GPU. So you even cannot install QPy on your. It will just say you have no CUDA and it will stop. So that's why we need HPC.
What about the integrated GPU? I think all one CPUs have.
If you have GPU, that's okay. Then you can install. But I guess on Macs you don't have GPU. So.
What about the integrated? Like there's always a pre-built basic GPU that.
You have graphic card, but this is different. GPU is the dedicated architecture. So that will not work. That we cannot run it on general on our laptops. And but what is important? You have the model. So the model is created. Of course, it loads the model. So the code is a bit more complicated, and that's why I said you are not required to read it, understand it like in full details, because it basically takes the model from a file. So the network, if you want to see how the network is constructed, you go to the generator models, and you open this generator Python, and here you can see how the layers of the network are put together. Okay, so this is like it reads from the configuration file where the model, in which file you have the specification of the model, and then you see that actually it's what we have seen last week. We create a network now, just that the network is much more complicated. It is much bigger. You have all the parameters which are in bigger numbers here, and also it first define something which is this convolutional layer.
The different layers use different activation functions.
And also different layers have different activation functions. This is right, exactly. So you see like this leaky ReLU and then ReLU. So they have also different. So but it's just an architecture, and we don't basically touch it. I mean, this is somebody tested it. It's good, it works. So then this is the structure of the generator. And then we can also see, but this is maybe not that interesting, but because we are not going to use it, here you can see how the discriminator is. I mean, this is the definition of the discriminator, whatever this means. I mean, this is like basically defining the second neural network for your model. And but if we go back to this main file, so you will see, okay, so we have the models, which are defined here. We have the optimizer, which we define here. The difference with the optimizer we were using the standard optimizer, the easy case. They use Adam, which is an adaptive optimizer, more advanced. For that, they also have to provide additional parameters, but these are technicalities. We don't really need to worry about this. We load the data set, we construct the iterator for training and for testing, and then we define the updater. So if you go, and finally we have these extensions. So it exactly follows the same structure or the same flow that we have seen last week, just that the network now is more complicated. And there is a little bit of more pre-processing, so they have all this cropping of images, cloud generation. The iterator has to merge files, clouds with RGB to generate the input for the network. But this we will see. Maybe this I don't want to say today. We will look at these more details next week when we go to this cloud removal, and then I will show you step by step how actually this is done. So the iterator. I'm just taking the part of the code from the just to clarify a bit what is happening, and then we will see how we can generate these images and how can we then for testing or for training, and then how can we remove the clouds and then see how compare with the original files, and then basically the report will be about redoing the same thing. So you train the network for a short, let's say, time, and for a few iterations, and then you compare with the let's say a network which is trained for a longer time, and then see, okay, how they behave, what is your observations when you compare the images, and how does this behave. But the idea is that you somehow play a bit and you get more skills with training and with the code, with running the example and writing a report, basically. But we will maybe look at this in more detail on the code next week. So now the crucial thing is to get as many environments ready for running. So you have already your Anaconda, like was mentioned for last week. We were running this case the exercise, and so the only thing I think, yeah, you have Chainer installed. So this should work without any problem now, so that once we have we can run the code locally. You can also check, maybe this is also once you, because you already have the files on Moodle, you can check if you can basically execute the first two, so just check if this runs. Matplot probably is no problem, so this should run. So if you can execute, load the libraries.
The CV2, it doesn't work for me.
CV2, so that one needs to be installed.
No, I don't install it.
The keyboard, the Y.
The nose Anaconda.
Because it's German one.
Yeah, that's why I went here. Here the Y.
Yeah.
CV2. Uninstall.
Maybe it's a good idea just to start and then install all pockets again.
That's what Dave is doing.
Yeah. David, how about you?
Open.
How about you?
Refresh the index.
I mean, this one from. Are they all installed properly, or you get some errors?
Now I have everything installed properly.
No, I think it's.
But you get do it in the second one, in the second time.
Yes, maybe.
But then
just overwrite.
No, I deleted everything.
Refreshing
Yeah.
So I deleted the script and I deleted the Anaconda 3 folder. And then I started with step 1 again.
Ah, okay.
Did you already have an Anaconda 3?
So open CD.
So according to the instruction to create on this your account local host
Yeah.
this computer.
There's no
There's
you
nothing.
started
It's
and
nothing.
then
Yes, from
you
this
went Ryan,
end.
then
Yeah.
deleted everything and just renamed it.
Yeah.
I don't know what was going on there. Trying again.
Did you do CMake?
I started.
It says CMake has to be.
Sorry, but this is
Sorry?
CMake. There's no.
Yes, it was, but it generates plenty of errors. But I don't know how it works. Just try it again. About this libraries, they can generate plenty of errors during the install.
To install. So one thing I will update this file because there is seems that I have to. So one thing you have to remember. I will put it there explicitly. After installing Anaconda, you log out.
I do it.
You log in again,
exactly.
and then you use these full paths.
Do you only log out from the
Seems that it's still necessary to use. It's safer to use all. And the install CMake before multitasking. But I will update the file and upload to Moodle.
When logging out, do we need to log out from the entire session or only from the node?
Session. Yeah, that's the thing. You have to log out completely because when you log again, then it loads the paths. From the, otherwise, it will not update the paths. And one thing, maybe trying to get it set up. If you have problems, don't wait till next week. You can come to my office and we can sit together and try to get it running. Because I think it's better that you have it done so that we can just go through the code, explain a bit of this, what is needed for the project instead of spending time on this. I mean, it's crucial, but we spend this time. So if you have problems, please just come to my office and I can try to help you so that you get this running. And then next week, and you can also tell to your colleagues if they were not here, that if they need help with this, they can come and we can sit together and I can help you to.
So you have to open
you can change this. We can help you to install the environment so that you are ready for next week.
And the HPC is available on the weekends and holidays?
No, not there.
I mean, no, you can use it all the time. Anytime. Of course, the support is not there, but you can submit your jobs, work anytime.
I'm using
Only problem is that we will see when we want to do the training. That's the kind of a bottleneck. So the training requires GPU, which means that we need to log into a node, access a node on the HPC which has a GPU. They are kind of limited, and for example, when I was preparing your files, this generator NPZ file to load, I had to wait 10 hours to get access. So I was even afraid that I will not make it because I submitted in the morning and it got around 11 p.m. on the HPC.
So,
run.
So, do you submit a job and then it waits, and then so you don't really know. You just kind of
they give you some kind of an estimate when your job will be accepted, running. Actually, for me it was even better. So they gave me an estimate like in 24 hours. I got it in 10 hours. So this is a little bit of a bottleneck, but it really depends. So sometimes you can get it quite quickly. And I had once this experience that I had to wait 10 hours to access the node.
Okay.
But this is just for training. The rest is you can do it on the normal node, and in fact you don't really need that because I kind of already prepared it for you. I give you the commands that actually in the case like they do in the paper, but it's like pre-done for you, so you don't really need to run it. We can immediately go for the training.
Just one time.
And then I will explain a bit the code so that you can then work with it for your
this
project.
is way again.
So did it work?
Which one?
It's not coming out.
It's not working.
But it didn't install then.
Which one?
The 7?
No, the username is also different though. It's not username, it's her name.
No.
So another option is the terminal.
That is separate from.
You just type.
If you want to delete everything.
We have to
So we have to, I don't know about
the
the
comma for
There's a comma,
just
yeah.
like
Yeah. So
and
you're-
then type
because
open
on
C.
the pass,
I can maybe
step
after the
A,
lecture.
we copy the zip from our machine to there, but we now we want it to know.
So
from there to our, so I don't know how, but yeah.
There's
Yeah.
folder.
there is nothing.
There's folders and file.
Okay, let me just.
Not able to
I-
find the HE, which
Okay,
is
I
created
feel-
by.
Then
Okay, so we are now basically done for today. So this was more like there were not that much of explain. Was more that you work with this HPC and the environment getting ready. So some of you have it done, some of you not. So my message is maybe please tell the others who are not here if you have any contact with them to try to install. If not, they can come contact me and let's have it done for the next week so that we can use the time to see something running and useful for the project. Okay?
Okay.
And if you have any problems, you can also come and.
Next class, where do we begin? I mean, next class, where are we starting? Do we start from where we are leaving today? The next
So
class?
next will be basically we will go through this cloud removal part. So then I will explain you the code, how this training and removal works basically. So just on the snippets of the code which are most relevant for you. So you have kind of the general idea, but then you will see the details of the cloud removal, only the parts which are necessary for you.
Okay.
Okay? And because I put these commands like how do you generate, crop these images and so on, but we actually don't need this that much because this is already pre-done for you. More important is that you can actually work with it and do something yourself. So this is what we are going to do next. Okay? Thanks.
Thank you. Thank you.
And let's see what's
Because you are the one to recognize the author. Okay.
Okay.
So I think Dave, how did you access your
I'm
phone?
quite happy because it's working.
To download the
It's not working.
I use the Win
or WinSCP.
Is it an application or?
Yes, application.
Then you can start
Hopefully the same.
terminals.
I'll try to go over it.
Install it. Then
We cannot do it using cookie?
No.
I'll try, but
No, it's even
University
If I go to
to
that
use
early,
this mobile.
okay,
It's
so.
working for progress. Okay.
Okay.
Wow. That's how we get the keys and that's all.
Oh, here.
There's a reception.
And if they don't have it, someone's already in there.
Right. And then we can
And
just.
if they don't have it at reception, someone's
Yeah.
probably already,
Yeah.
right?
That's it. Yeah. So then we can try here. Let's go on this. And then just open
Yeah, I plan to come to go to bed early
this
and then wake up.
dash next. Horizontal. Again. And then those punches. Yes.
Alright, I'm just gonna ask you right now.
What?
And what is page?
Yeah, yeah, it's okay. Yeah, sorry.
What is page and
Yeah, it's weird, right?
Yeah, and what am I supposed to
And if you can start restart the Anaconda and then see if we can run that.
So, okay, this goes back up.
It's
Goes back up.
I don't know how to do that. Using SCP. For the file transfer.
Yes.
Lower loss,
So here.
here. Does it fit?
You downloaded it?
I don't know.
You need to install it.
Here you have
Yeah.
this oscillating.
This is the first?
Okay.
Yeah, that's the.
So you need to
what they have.
provide the.
Mhm. But you also
You have
have to
the
check this
agent,
like
yeah,
it's
I-
different scales too. So if you see here,
Is
it's
it
over
190
90.
degrees?
Yeah,
So,
and here is barely reaching 90. So
so it's
from-
more accurate.
yeah, it's more accurate. And it was for I didn't have this. I have a better thing here.
Really?
Yeah, exactly.
And then you open and see. So this is like Windows. So you just double click right and see that. And then you take your file and download it.
It's the laws, right?
Yeah.
Yeah, and then the copy is.
This is what I did. It's gonna go up like.
Upload, yeah.
Look at, okay, so you just put this one here.
Progress.
Still relevant, so here and there. Did you mess with it?
It's for the very good side.
So it's the point 781 for the last one from the list.
Then this is the same.
Yeah, you are finishing this.
The 8, and there is one more. There is one more, but
Oh,
this is
that's
not.
no, it's
Now it's so you can try.